Right, in this video, we're going to talk about section 2B, which is extending unit analysis. And pretty much a taste of this was introduced in section 2A, but here we're going to go into more detail with unit analysis. Okay, so here we can use units to help solve practical problems involving energy density and concentration. So here in this section, we're going to turn our attention to understanding the units for solving these problems, starting with an overview of the two commonly used systems of standardized units. Okay, now we're going to start with the unit systems, excuse me. In the United States, most of our daily measurements are made with what is often called the English system of units, but is more formally known as the customary system, or the U.S. customary system, abbreviated USCS. The rest of the world use the international metric system known by the abbreviation SI through customary units, though customary units are sometimes still used for non-official purposes. All right, so those are the two units of standardized, systems of standardized units that we're going to be using or talking about in this section. One of them, of course, is the U.S. customary system. This system has roots dating back thousands of years, and its units became standardized in often surprising ways. Now, the table that I'm going to show you in this video does summarize the official U.S. customary system showing standardized units of length, weight, and volume. Okay, now let me pull this paper down so that way you can see that table of the U.S. customary system of measurements, and the common abbreviations are in parentheses. Now, I won't go through all of these in this video, so pretty much try to be familiar with these units here, and you're not required to memorize these as well. It's not expected that you're going to memorize all of these, but try to be familiar with at least some of these if at all possible, because we're going to be using the U.S. customary system of measurements for length, width, and volume to do some conversion from one unit to another, like in the first example. And it says here, a certain race is a distance of 24 furlongs. How far is the race in A, miles, and B, yards? Okay. So in this case here in part A, we're trying to find out, we want to convert furlongs to miles. 24 furlongs is going to be how many miles? That's really what they're asking for. So we start off with 24 furlongs. Now, in this case here, for 24 furlongs, if we can find it here, we're converting from miles. So here, 24 furlongs, one furlong is equivalent to 1/8 of a mile. 24 furlongs is 1/8 of a mile. So here we're going to multiply using unit analysis. We're converting from furlongs, so that means the furlongs has to go in the denominator. We're converting to miles, so miles goes in the numerator. Notice that I'm abbreviating miles. We're told that 1/8 of a mile is 1 furlong, so 1/8 goes in the numerator, the 1 goes in the denominator. I put the numerical values with their appropriate units, okay? Because 1 furlong is 1/8 of a mile. Now, when I simplify this, the furlongs divide out. I'll be left with just an answer in miles. So if I do 24 times 1/8, or of course, 24 divided by 8 would be 3. And this is going to be in miles. So 24 furlongs is equivalent to 1/8 of a mile. Okay. Now, part B, we want to convert this to yards. Well, we know 24 furlongs is 3 miles, so let's take that 3 miles here, convert that to feet. Now, going back to our table here, 1 mile is equivalent to 5,280 feet. So we're converting from miles, so the miles goes in the denominator. We're converting to feet. The feet has to go in the numerator. So here we put the appropriate values with their units. 1 mile, the one goes in the denominator, is equivalent to 5,280 feet. So the 5,280 goes in the numerator. Now, when we simplify this, you're going to see that the miles divide out. And then I'm going to multiply. Oh, I'm sorry. This says yards. Okay, I need to change that. Okay. 1 mile is 1,760 yards. Because in part B, we're converting to yards. So instead of 5,280, that should be 1,760. And this should be yards. Okay. So now we do three times 1,760 yards, which will be 5,280 yards. So 3 miles is equivalent to 5,280 yards. Okay. So you have to pay close attention to what you're converting from and what you're converting to. In this case, we're converting from to yards. So 24 furlongs in yards would be 5,280 yards. Okay. All right, number 2, the depth of a certain part of the Earth seabed is 36,042 feet. How deep is it in fathoms, which is part A, and in leagues, which is a unit of measurement used in marine. All right, so let's start with fathoms. So here we're going to be converting from feet to fathoms. So here we got 36,042 feet. Now, according to our table, let's look at this here. If you look here, 1 fathom is equivalent to 6 feet. 1 fathom is equivalent to 6 feet. And we're going from feet to fathoms. So what we're converting from goes in the denominator, that's the feet. We're converting 2 fathoms, that's going to go in the numerator. That unit goes in the numerator. Now 1 fathom is equivalent to 6 feet. So the 1 goes in the numerator with the fathom. The 6 has to go in the denominator with the feet. So you're going to see the feet divides out. We're going to be left with 36,042 divided by 6. And if you were to do this on the calculator, you'll end up with 6,007 fathoms. 6,007 fathoms is equivalent to 36,042 feet. Now in part B, we got leagues. We want to convert to league. All right, now let's look at this here. We see that 1 league used in marine is going to be 3 nautical miles. Okay. I also know this, since I can't immediately use this, I need to use this fact first, that 1 nautical mile is equivalent to, in this case, since I got feet, 6,076.1 feet. So I need to convert from feet to nautical mile, and then from nautical mile to league. Okay, so I have to do 2 different conversions here. Okay, so let's start with that 36,042 feet. That's going to be multiplied by, we know 1 nautical mile is 6,076.1 feet. So the nautical mile goes in the numerator. And we're converting from feet, that goes in the denominator. So here 1 nautical mile is 6,076.1. That goes with the corresponding feet, or corresponding unit in this case. So feet divides out. You'll be left with an answer in nautical mile. However, we need to convert from nautical mile to league using this. 1 league is 3 nautical miles. All right, so now I'm going to multiply this time. So I'm going from nautical miles, so the nautical mile goes in the denominator. And the league goes in the numerator. So the 1 league, the 1 goes in the numerator, is equivalent to 3 nautical miles. The 3 goes in the denominator with the unit nautical mile. So nautical miles divides out. So your answer will be left in league. So here, this is where we go ahead and use our calculator to come up with our answer. So in this case here, clear this out, 36,042 will be divided by, I'm going to do this in parentheses, 6,076.1 times 3. And the final answer there will be, if we were to round this off to 2 decimal places, this will end up being 1.98. And it's going to be in league. So 36,042 feet is equivalent to 1.98 league. Okay. All right, now, number 3, example 3. 1 cubic foot holds 7.48 gallons of water, and 1 gallon of water weighs 8.33 pounds. How much does 8.1 cubic feet of water weigh in pounds and in tons? All right, so this is what you're given. You're told that a cubic foot of water holds 7.48 gallons. So this is like 7.48 gallons, and I'm going to abbreviate for 1 cubic foot. That's how we will write 1 cubic foot. And 1 gallon of water holds 8.33 pounds. So it's going to be 8.33 pounds per 1 gallon of water. So let's answer this question. How much does 8.1 cubic feet of water weigh in pounds? All right, so got 8.1 cubic feet. And we want to go from cubic feet to pounds. Well, looking at this, you can't do it directly. However, we can use the fact that out here. Here we go. We can use the fact that the 7.48 gallons is equivalent to 1 cubic feet, and the fact that 8.33 pounds is 1 gallon. We can use these to help us convert from cubic feet to gallons. I mean to pounds. So let's multiply this by this unit right here. This equivalency, 7.48 gallons has to go in the numerator. 1 cubic feet goes in the denominator because that's what we're converting from. And you can see cubic feet divides out. Our answer will be in gallons. Now we're going to use this to help us get our answer in pounds. Since 8.33 pounds is equivalent to 1 gallon, let's multiply that as well. 8.33 pounds per 1 gallon. And here the gallons divides out. So now we're going to do 8.1 times 7.48 times 8.33. Rounded to 1 decimal place, this will be 504.7. The second digit after the decimal point is a 9. It's bigger than 5, so the 6 increases to a 7. So it'll be 504.7 pounds. And this is the abbreviation for pounds, LBS. Now, we want this in tons as well. All right, so we're going to convert 504.7 pounds to tons. Well, from our table, I do know something here. 1 ton is 2,000 pounds. 1 ton is equivalent to 2,000 pounds. And we're converting from pounds that goes in the denominator to tons. So 1 ton, the 1 goes with the ton, is equivalent to 2,000 pounds. So the 2,000 goes in the denominator with the pounds. That way your pounds, the unit of pounds, divides out. So you're going to do 504.7 divided by 2,000. And to 2 decimal places, this will end up being 0.25 pounds. Not pounds, 0.25 tons. Okay. Okay. All right, on the next page is this. What is your average speed in miles per hour and in feet per second if you travel a mile in 25 minutes? Okay. So we're looking at 1 mile in 25 5 minutes. And the way we can write that would be 1 mile divided by the 25 minutes. I'm going to abbreviate minutes like this. And we want our average speed in miles per hour. Well, we got miles per minute. Okay, so we got to write it in terms of miles per hour. Well, we already got the miles here. I do know something here that 1 minute, I'm sorry, 60 minutes, 60 minutes. 60 minutes is equivalent to 1 hour. 60 minutes is equivalent to 1 hour. So we can use that equivalent phrase to convert that from miles per minute to miles per hour. Well, to divide out the minutes needs to be in the numerator. And it's 60 minutes, so that 60 goes with it. 1 hour goes in the denominator. So you're going to see the minutes divides out. It will be in miles per hour. So we're going to have 1 times 60, which is 60. 60 divided by 25 will be 2.4. So we're going to get 2.4 miles per hour. Okay, so this is in miles per hour, and also we need feet per second, okay? So I'm still going to use that 1 mile over 25 minutes. Now, if we want this in feet, we also know something here, that 1 mile is equivalent to 5,280 feet. 1 mile is equivalent to 5,280 feet. Okay, so we're converting from miles, so the miles go in the new denominator. We're converting to feet, feet goes in the numerator. Miles have to go in the denominator. The 1 mile, the 1 goes in the denominator, is equivalent to 5,280 feet. So 5,280 goes in the numerator. So here the miles divide out. We only got feet per minute. We want feet per second. Well, in this case here, 1 minute is 60 seconds. 1 minute is 60 seconds. All right. We need seconds to go in the denominator. And the minutes have to go in the numerator. So 1 minute, the 1 goes in the numerator, is equivalent to 60 seconds. So the 60 goes in the denominator. So here, your minutes are going to divide out. Your answer will be in feet per second. So if I do the math here, 5,280 feet. This will be divided by, and I know I'm going to have to do 25 times 60. Notice I put that in parentheses. Let's see, to 1 decimal place, this will be approximately 3.5. So in feet per second, the average speed is 3.5 feet per second. Okay. All right, example number 5 is a price comparison. Here we use price comparisons to determine which one is a better buy. And usually the lowest price per unit would be the better buy. All right, so here we're going to decide which of the two given prices is the better deal and explain why. And here it says here you can buy shampoo in a 6-ounce bottle for $4.99 or in a 14-ounce bottle for $11.19. All right, so let's look at the 6-ounce bottle. I'm going to take the price of that 6-ounce bottle, which is $4.99, and divide that by the number of ounces in that bottle, 6 ounces. Now, in this case, I'm going to round, since we're dealing with money amounts, I'm going to round to 2 decimal places. So 4.99 divided by 6 would be approximately 83 cents. So the unit cost would be 83 cents per ounce. $0.83 per ounce. And now for the 14-ounce bottle of shampoo. It costs $11.19. So I'm going to take the $11.19 and divide that by the 14 ounces. Which will end up being, let's see, if we round this off to 2 decimal places, this 9 will make the 9 in front of that 0, and then the 7 will be 8. So it'll be 0.80 or 80 cents per ounce. 80 cents per ounce. All right. Now, the smaller of the two unit prices is the best buy or the better deal. So if you look at this, you're going to see 80 cents per ounce is smaller than 83 cents per ounce. So the 14-ounce bottle would be the better deal. So we can just say the 14-ounce bottle of shampoo is the better deal. Okay. All right, here's another example that does a price comparison. You can fill a 12-gallon tank of gas for $40.38 or buy gas for $3.20 a gallon. And we want to decide which of the two given prices is a better deal. Okay. So here we have a 12-gallon tank. 12-gallon tank. We want to fill it with gas. The cost to fill that up would be $40.38. And we got 12 gallons to fill it up. So if we divide $40.38 by 12, to 2 decimal places, that would be approximately 3.37 or $3.37 per gallon. Now we're going to compare that by buying gas for $3.20 per gallon. You can easily see that the better deal would be to buy gas for $3.20 a gallon. So we'll say the better deal is to buy $3.20 to buy gas at $3.20 a gallon. All right, so that's how we determine which price is a better deal. Okay, now let's look at the international metric system. The international metric system. It was invented in France in the late 18th century for two primary reasons. One is to replace many customary units with just a few basic units. And second, to simplify conversions through the use of a decimal system, which is, of course, the base 10 system. So here, the basic units of length, mass, time, and volume in the metric system are as follows, okay? For length, it's going to be the meter, which is going to be abbreviated lowercase m. For mass, it would be the kilogram, abbreviated kg. For time, it's going to be second, abbreviated by the lowercase letter s. And for volume, it will be the liter, abbreviated with the capital L. Okay, so each of these basic units can be combined with a prefix that indicates multiplication by a power of 10. Now, the table that you see here lists the common metric prefixes. So here they are. So do pretty much get familiar with those as well. I'm not going to take the time to go over it, read out every last one of them. So do be familiar with those and know how to use those metric prefixes, because they're all pretty much using the power of 10, okay? The small values here are right here: deci, centi, milli, micro, nano, and pico. Notice that their exponents are negative. The large values have their positive exponents for the base of 10: deca, hecto, kilo, mega, giga, and tera. Now we're going to be using that to help us solve some of these problems here, like in example 7. All right, it says here that we're going to complete the following sentence with a power of 10 greater than 1. Like in this case here, a gigameter. A gigameter is how many times as large as a meter? Okay. Well, if you look at giga, the exponent for 10 is going to be 9. Okay. That value is, of course, 1 billion, but here's 10 to the 9. The base unit for length is going to be meter. So that means from meter to gigameter, that's 10 to the 9th. So a gigameter is going to be 9 times as large as a meter. 9 times. All right, now let's look at this example right here, where it says here, a megagram is how many times as large as a nanogram? Let's look at megagram. The exponent for megagram is 6. Well, for nanogram is -9. So to find out how many times as large as a nanogram, we need to subtract 6 minus -9. Because the megagram has the exponent of 6, nanogram has the exponent of -9. So to find out how big that is, how many times as large a megagram is as a nanogram, we need to subtract 6 minus a -9. And of course, when you subtract, you're always going to add the opposite of the second number. So it'd be 6 plus 9, which is 15. So here a megagram is 15 times as large as a nanogram. Okay. All right, here's another example of this. Let's say a gigameter is how many times as large as a picometer or picometer, however you pronounce it. All right, we got to do some subtraction here because a gigameter has the exponent as 9 as the power of 10. So it's going to be 9 minus the picometer is 10 to the negative 12. So we need to subtract negative 12 from 9. So here 9 minus a negative 12, that's pretty much the same as saying 9 plus 12, which is 21. So a gigameter is 21 times as large as a picometer. Okay. All right, now let's say we have something like this, the metric Uscs conversions. Here we're going to carry out conversions between metric and Uscs units like any other unit conversions. And again, USCS means United States Customary System. The table below lists a few handy conversion factors. It is useful to memorize approximate conversions, particularly if you plan to travel internationally or if you work with metric units in sports or business. Okay, so here's that table. Now, again, I'm not going to take the time to cover all of these. Okay. But do get familiar with those units. Okay, because we'll be using those to answer some of the problems or solve some of the problems in this video. Like in example 10. A bag of garden soil weighs 40 pounds and holds 3 cubic feet. Find the weight of 15 bags in kilograms and the volume of 15 bags in cubic yards. Okay. Now there is something that we do need to know right here. We need to know that 1 pound is 0.4536 kilograms. So I'm going to write that down. 1 pound is 0.4536 kilograms. And we're told that a bag of garden soil contains 40 pounds. And it holds 3 cubic feet. So here, let's convert 40, well, at least write this out. 1 bag does weigh 40 pounds. And let's convert that to kilograms using this, the fact that 1 pound is 0.4536 kilograms. All right, so I'm going to multiply this by, we're converting from pounds, so the pounds go in the denominator to kilograms, so kilograms go in the numerator. Well, we got 0.4536 kilograms to 1 pound. So here the pounds divide out. So I'm going to be multiplying 40 times 0.4536. That will give me, to 2 decimal places, 18.14 kilograms. Okay, so 1 bag is equivalent to 18.14 kilograms. Now let's find the weight of 15 bags. So here we got 15 bags. That's going to be multiplied by we found out that one bag is equivalent to 18.14 kilograms. Okay, so we're finding the weight of 15 bags in kilograms. So the kilograms go in the numerator. And of course, the one bag goes in the denominator. So one bag is 18.14 kilograms. So 15 times 18.14 is equivalent to the nearest whole number will be 272 kilograms. And of course, in the homework, do pay close attention to how they want you to round off your final answer. They might want you to round off to the nearest whole number. They might want you to round off to the nearest 10th or the nearest 100th, but do pay close attention on how they want you to round off your final answers. That's to these problems in the homework. All right, the other part is finding the volume of 15 bags in cubic yards. Okay. I think there's something in here about cubic yards. I'm going to go back to this table right here, where you got 1 cubic yard equaling to 27 cubic feet. 1 cubic yard is equal to 27 cubic feet. Now write that down. And it holds 3 cubic feet. The bag of garden soil, 3 cubic feet. So let's convert that to cubic yards by putting the cubic feet in the denominator and the cubic yards in the numerator. So 1 cubic yard would be 27 cubic feet. So the 1 goes in the numerator and the 27 goes in the denominator. So that way you'll see that your cubic feet divides out. So here, this will be 3 over 27. That's in cubic yards. But here we can reduce 3 over 27 to 1/9 by dividing the numerator and the denominator by 3. So it'd be 1/9 cubic yards. One-ninth of a cubic yard. Now for the volume of 15 bags. Let's keep in mind volume is in cubic units, so we already have cubic yards. So the volume of 15 bags would be this. Take your 15 bags, multiply that by, now of course, 1 bag holds in cubic yards, 1/9 of a cubic yard. So I'll take 1/9 of a cubic yard, divide that by 1 bag. So bags divide out. 15 times 1/9. And I'll go ahead and do this. 15 times 1 divided by 9. Let's say the 1 decimal place, that would be approximately 1.7 cubic yards. So the volume of 15 bags would be 1.7 cubic yards. Okay. All right, let's look at this next example here, number 11. A boat has a top speed of 26 knots and a displacement of approximately 88,000 tons. Express the top speed in miles per hour and the displacement in metric tons, TONNES. And you're told that 1 knot is equal to 1 nautical mile and 1 metric ton, TONNE, is 1,000 kilograms. All right, let's start with the top speed. All right, we got 26 knots. That's multiplied by. Now, you already told that 1 knot is equal to 1 nautical mile per hour. Okay. So here I'm going to multiply that by. Now, the numerator is going to be 1 nautical mile per hour, because I'm converting from knots. So I know 1 knot goes in the denominator. The 1 nautical mile per hour goes in the numerator. The knots divide out, you'll be left with a nautical mile per hour. Now, going back to this table here, I also know that for 1 nautical mile, if you recall, 1 nautical mile is going to be equivalent to 6,076.1 feet. Okay, I'm using that because I want this to be in miles per hour. And I know that 1 mile is equivalent to 5,280 feet. Okay, but I need to get from nautical miles, in this case, to feet, and then from feet to miles, because 1 mile is 5,280 feet. All right, so here's what I'm going to do. I'm converting from nautical miles. So the 1 nautical mile, I'll have to abbreviate here, is equivalent to 6,076.1, and that's in feet. So the feet goes here. All right, now you're going to see that your nautical miles divide out. So now my answer is going to be in feet per hour, but I want this in this case, miles per hour. Well, I know that 5,280 feet is equivalent to 1 mile. So we're converting from the feet. The feet has to go in the denominator. And then the miles goes in the numerator. So 1 mile, which is the 1, goes in the numerator, is equivalent to 5,280 feet. That goes in the denominator. You're going to see your feet divides out. The final answer will be in miles per hour. So now let's multiply all of this out. So here we got 26 times 6076.1. That's that. And we're going to divide that by 5,280. All right, to 1 decimal place, this will be 29.9 miles per hour. So it'll be 29.9 miles per hour as the top speed in miles per hour. Now we want to convert the displacement, write that in metric tons, T-O-N-N-E-S. So we got 88,000 tons, T-O-N-S. We want to go to metric tons. Well, I know for a fact that 2,000 pounds makes up 1 ton, T-O-N. Let's start there if we can. So here, 1 ton that goes in the denominator, that's equivalent to 2,000 pounds. So here the tons divides out. My answer will be in pounds. But I also got to use something else that to use the fact that that 1 pound is 0.4536 kilograms. Okay, because I'm given the fact that 1 metric ton is going to be 1,000 kilograms here. All right, so I'm going to convert that by using this. The fact that 1 pound that goes in the denominator is equivalent to 0.4536 kilograms. Now the pounds divides out. My answer would be in kilograms, but of course, 1,000 kilograms is a metric ton. So now I can easily convert from kilograms, which will be in the denominator, to metric tons. So of course, 1 metric ton, the 1 goes in the numerator, is equivalent to 1,000 kilograms. So in this case here, your kilograms divides out. Now we got to multiply all of this out and do some division as well. So 88,000 times 2,000 times 0.4536. And we can divide that by 1,000. To the nearest whole number, this will be approximately 79,834 metric tons. Okay. All right, that would be the final answer to that. Okay. Now I realize that I gave you a more complicated problem for this one, because you have to think about the fact you're going from kilogram. You want to get to kilograms, but you have to go from, here's the fact that 2,000 pounds is a ton, and the fact that 0.4536 kilograms is a pound, and then you have the fact that 1 metric ton is 1,000 kilograms. So you have to go through all that just to get that final answer. Okay. All right. Now, these other examples are kind of less complicated, but you still have to use the use your conversion tables here. Like in this one, 31 liters is going to be how many quarts? You want to convert from liters to quarts. Well, the fact is, 1 quart is 0.9464 liters. Or you could use this better yet, since we're going from liters to quarts. 1 liter is going to be 1.057 quarts. Okay, so now we got 31 liters, which I'm going to abbreviate with a capital L. That'll be multiplied by, and I know the fact that 1 liter is 1.057 quarts. So going from liters, that means that the 1 liter has to go in the denominator to quarts. So the 1.057 quarts goes in the numerator. The liters divides out. So that means we got 31 times 1.057. And they want this to 1 decimal place. So this will be approximately 32.8 quarts. 32.8 quarts. That's what 31 liters is equivalent to. Okay. All right, here's the next example. Using that table provided, we want to convert 35 pounds to kilograms. Okay, so we see here 1 pound is 0.4536 kilograms. So 35 pounds, abbreviated LBS, we're going to multiply that by, we're converting from pounds, so the pounds goes in the denominator, the 1 goes with it. That's equivalent to 0.4536 kilograms. That would go in the numerator. You're going to see the pounds divides out. So it'll be 35 times 0.4536. Let's say the 2 decimal places, your answer there would be 15.88. So it'll be 15.88 kilograms, which is equivalent to 35 pounds. Here's another example, number 14. Convert the following quantities to the indicated units. Convert the following quantities to the indicated units. Let's say here 9 square kilometers is, we want to convert 9 square kilometers to square kilometers. Well, the problem is we don't know what square kilometers is, but we do know something here from the table that 1 square kilometer okay. 1 square kilometer is equivalent to 0.6214 miles. Okay, and here it is right here. 1 kilometer is 0.6214 miles. That we know from that conversion table. I take that back. It's just 1 kilometer, not square kilometers. Okay. 1 kilometer is just equal to 0.6214 miles. That's this. Now to find square kilometers, all we do there is just simply square both sides of this equation. So I'm going to square both sides. Okay, 1 squared will be 1. The kilometers will be squared. Now I'm not going to square that 0.6214. I'm just going to write like 0.6214 and then squared. And the miles will be squared. That's what 1 square kilometer will be. Now we want to find out what we want to convert 9 square kilometers to square miles. Okay, so 9 square kilometers will be this. The kilometers squared, we're converting it from, goes in the denominator with the 1. So that means 0.6214, and that's squared. Miles squared goes in the numerator. That way your square kilometers divides out. You'll be left with an answer in square miles. So if I do 9 times 0.6214 and we square it to 1 decimal place, that would be approximately 3.5. So this would be 3.5 square miles. That's the equivalency to 9 square kilometers. Okay. All right, here's the next example. convert the following quantities to the indicated units here. We got 56 miles per hour. We want to convert that to meters per second. So 56 miles per 1 hour. And I want to convert that to meters per second. Well, I do know the fact that let's look at this. We know the fact that 1 mile is equivalent to 1.6093 kilometers. 1 mile is equivalent to 1.6093 kilometers. Let's start there. So here I'm going to multiply what 1 mile is. That one has to go in the denominator. And we're going from 1 mile to kilometers. The kilometers equivalent is 1.6093. Okay. So here you're going to see your miles divide out. You'll be left with kilometers per hour. We want this in meters per second. Well, kilometers, 1 kilometer is 1,000 meters. That's one of our prefixes. Kilo is the equivalent of 1,000. So 1 kilometer is 1,000 meters. So let's use that. Convert from kilometers to meters. Meters goes on top, kilometers goes on the bottom. The 1 goes with the kilometers, the 1,000 will go with the meters. So here, kilometers divides out. We got meters per hour. We want meters per second. We have to use the fact that 1 hour is 60 minutes. And we also have to use the fact that 1 minute is 60 seconds. So in this case here, let's start with the hour. Get rid of the hour by putting the 1 hour in the numerator and the 60 minutes in the denominator. So you'll see the hours divide out. You'll be left with meters per minute, but we want meters per second. So that's where we use that the fact that 1 minute is 60 seconds. 1 minute goes in the numerator, 60 seconds goes in the denominator. Here the minutes divide out, so the final answer will be in meters per second. Okay, so here we're going to do 56 times 1.6093 times 1,000. Then that's going to be divided by the 60 times 60. I'm putting that in parentheses. And as our final answer to 1 decimal place, this will end up being 25.0. And the answer will be in meters per second. Okay. All right, now here's one more of these conversions. Convert 345 cubic inches to cubic centimeters. Well, the fact is that 1 inch is 2.540 centimeters. 1 inch is 2.540 centimeters. All right. But for cubic inches, we need to cube both sides. Cubic inches, we cube both sides. So 1 cubed is going to be 1, and this will be in cubic inches. And I'm just going to write this as 2.540 cubed, centimeters cubed. And now we can convert from cubic inches to cubic centimeters. Okay, we have 345 cubic inches. We're converting from cubic inches, so the 1 cubic inch goes in the denominator, 2.540 cubed cubic centimeters goes in the denominator. I mean, in the numerator, the 1 cubic inch goes in the denominator. Your cubic inches divides out. So we got 3 times 2.540. And that's going to be raised to the third. I'm sorry, correction, 345 times 2.540. That's raised to the third. To 2 decimal places, that would be 5,653.54 cubic centimeters. (5,653.54 cubic centimeters for 345 cubic inches. Okay. All right, so that deals with converting from metric to the customary units and vice versa. All right, next we'll look at the standardized temperature units. All right, this is another important set of standardized units are those we use to measure temperature. 3 temperature scales are commonly used. One is the Fahrenheit, the Celsius, and the Kelvin scale. The Fahrenheit scale commonly used in the United States is defined so water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The rest of the world uses the Celsius scale, which places the freezing point of water at 0 degrees Celsius and the boiling point at 100 degrees Celsius. In science, we use the Kelvin scale, which is the same as the Celsius scale, except for its 0 point, which corresponds to negative 273.15 degrees Celsius. A temperature of 0 Kelvin is known as absolute zero. That is because it is the coldest possible temperature. Now, the degree symbol here is not going to be used in the Kelvin scale. And here you can see an illustration of just the temperature scale for Fahrenheit, Celsius, and Kelvin. Okay. So here the definitions of these 3 temperature scales lead to simple formulas for converting between them, summarized in this box below. Okay, so here you can see here to convert from Celsius to Fahrenheit, what you'll do there in words, they tell you to multiply by 1.8 or 9/5, then add 32. So here's the conversion formula. F is equal to 1.8 times the Celsius temperature plus 32. Now to convert from Fahrenheit to Celsius, in words, you'll subtract 32, then divide by 1.8, which is 9/5, or equivalently multiplying by 5/9. And the formula, the conversion formula, C is equal to F minus 32, the Fahrenheit temperature minus 32. That difference is divided by 1.8. Now from Celsius to Kelvin, you just simply add 273.15. So Kelvin is the Celsius temperature plus 273.15. And then from Kelvin to Celsius, you're going to subtract 273.15. And here's the conversion formula for that. C is equal to K minus 273.15. Okay. Now let's look at some examples of doing this. We're going to convert the following temperatures from Fahrenheit to Celsius or vice versa. Starting with part A, we got 75 degrees Fahrenheit. We want to convert that to Celsius. As we know the Fahrenheit temperature, we're going to convert to Celsius. Okay. In this case, to convert to Celsius, we have to use this formula here. F minus 32. The whole thing's divided by 1.8. So F, the Fahrenheit temperature, 75 degrees, minus 32, divided by 1.8. Let's subtract 32 from 75. That would be 43 divided by 1.8. To one decimal place, that would be approximately 23.9. And this is going to be 23.9 degrees Celsius. All right, so that's part A. Part B, 80 degrees Celsius. We want to convert this to Fahrenheit. So we need to use this formula. F is equal to 1.8 times the Celsius temperature plus 32. So F is equal to 1.8 times C plus 32. The Celsius temperature is 80 degrees plus 32. So he would do 1.8 times 80 plus 32. You'll get 176. So the temperature in Fahrenheit, in degrees Fahrenheit, is 176 degrees. Now part C is negative 35 degrees Celsius. Negative 35 degrees Celsius. Here we want to convert that to Fahrenheit. So we use that same formula. F is equal to 1.8 times the Celsius temperature plus 32. So here 1.8 times the Celsius temperature is negative 35 plus 32. So negative 1.8 times negative 35 plus 32 ends up being negative 31 degrees Fahrenheit. So that's the Fahrenheit temperature for negative 35 degrees Celsius. Okay. All right, this next example deals with Celsius to Kelvin and vice versa. Convert the following temperatures from Kelvin to Celsius or vice versa using these two formulas here. All right, in part A, we got 55 Kelvin. And I'm going to convert that to degrees Celsius. So here I have to use C is equal to K minus 273.15. So your K is 55, so this will be 55 minus 273.15. So I'm going to do 55 minus 273.15. It's going to be negative, so it'll be negative 218.15 degrees Celsius. (218.15 degrees Celsius). Part B is 180 Kelvin. We need to convert that to Celsius as well. So it'll be C is equal to K minus 273.15. Your K, Kelvin, 180, minus 273.15. So 180 minus 273.15 is equal to negative 93.15 degrees Celsius. All right, now part C is 25 degrees Celsius. This time we're converting it to Kelvin. So the K is equal to C plus 273.15. The Celsius temperature is 25. So 25 plus 273.15 would be 298.15 Kelvin. All right, let's talk about in units of energy and power. Units of energy and power. Now we're going to extend unit analysis to problems involving energy and density and concentration. We'll start with energy, which is what makes matter move or heat up. We need energy from food to keep our hearts beating, to maintain our body temperatures, and to walk or run. A gasoline-powered car uses energy to move the pistons in the engine, which turns the wheels. A light bulb needs energy to generate light. For Americans, the most familiar energy unit is the food calorie, which is a capital letter C. That's used to measure the energy our bodies can draw from food. The international metric unit of energy is called the joule, Joule. And here I have highlighted 1 calorie is equivalent to 4,184 joules. Now, there is a difference between energy and power. Energy in this case is what makes matter move or heat up. And of course, the international metric unit is the joule. Power is going to be the rate at which energy is used. And its international metric unit is going to be the watt. And here's its equivalency right here. 1 watt is going to be equivalent to 1 joule per second. Because keep in mind, power is a rate. It's usually a unit over time. So here, 1 watt is 1 joule per second. All right, now let's use this to answer this next example, number 19. Assume running consumes 100 calories per mile. If you run 11-minute miles, what is your average power output in watts? Okay. So we got 100 calories per mile. So I'm gonna write like this, 100 calories per 1 mile. And I did mention that 1 calorie is equivalent to 4,184 joules, as I have highlighted here. So let's use that fact. So we're converting from calories, so the calories goes in the denominator, and it's 1 calorie, so it'll be a 1. Joules will go in the numerator. That's the 4,184. You're going to see calories divide out. So we got joules per mile. But since 1 watt is joules per second, we want to convert this to joules per second. You're running 11-minute miles. That means for every 1 mile, it takes you 11 minutes to run 1 mile. So this means 1 mile is equivalent to 11 minutes. Let's do this. Put the 1 mile in the numerator because I'm going to divide that out, and the 11 minutes goes in the denominator. Okay. Miles divides out. Now, I also know something here. 1 minute is 60 seconds because I want this in joules per second. So let's use that fact to divide here. The 1 minute goes in the numerator. 60 seconds goes in the denominator. Your minutes divides out. You'll have this in joules per second, but of course, joules per second is equivalent to 1 watt. So let's go ahead and divide this, well, simplify this, 109 times 4,184. That's going to be divided by, in parentheses, I got 11 times 60. So the nearest whole number will be 691. So it'll be 691 joules per second. But of course, joules per second is equivalent to a watt. So in this case here, the average power output in watts will be 691 watts if a person consumes 109 calories per mile by running. Okay. Now let's look at electric utility bills here. On utility bills, electric energy is usually measured in units of kilowatt hours. So here, a kilowatt hour is a unit of energy. And here's the equivalence. 1 kilowatt hour is 3.6 million joules. Now, if we were to write this out, this would be 3,600,000 joules for 1 kilowatt hour. All right, now let's look at this example here. Your utility company charges 11 cents per kilowatt hour of electricity. Complete parts A and B below. What is the daily cost of keeping lit a 50-watt light bulb for 10 hours each day? Okay, let's start with part A. Here we got a 50-watt light bulb. Okay. Now we want to convert that to kilowatt hours, well, to kilowatts. Well, kilo is the prefix for 1,000. So 1 kilowatt is going to be 1,000 watts. Okay. 1 kilowatt, since the prefix kilo is 1,000. So it'll be 1,000 watts. So the 1 kilowatt goes in the numerator, and 1,000 watts has to go in the denominator. Of course, the watts divides out. Now we're doing 10 hours each day. So 10 hours per 1 day will be this. We'll multiply that. We also know that we'll charge 11 cents per kilowatt hour. Well, notice here, kilowatt hours here, if I multiply that. But for every 1 kilowatt hour, I'm charged 11 cents. Okay. So kilowatt hours divide out. I'm left with an answer in dollars per day. All right, so we need to simplify this a bit. Figure this out. Let's do 50 times 10 times 0.11. That's going to be divided by 1,000. So it'll be 0.055. And that's in dollars, by the way. 0.055, which is a little bit more than 5 cents per day. Okay. So for 10 hours a day, the daily cost would be $0.055 per day. So that's part A. Part B, it says, how much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light using only 10 watts of power? Okay. All right, so let's do this here. We got $0.055 per day. And there are 365 days in a year. So if I do 365 days per 1 year, $0.055 times 365, that would be $20.075 per day. Okay. But let's say we use only like 10 watts of power from this light bulb. The fact is that 1,000 watts is equivalent to 1 kilowatt, because we want this in kilowatt hours, by the way. So 1,000 watts will go in the denominator. Now I'll put the 1 kilowatt in the numerator, just like I did in part A. That way your watts divides out. Okay. And the 10 is 10 hours per day. In this case here, because we're doing 10 hours each day, by the way. So it'd be multiplied by 10 hours per 1 day. And of course, for each kilowatt hour, it's 11 cents. Now I'm going to abbreviate kWh for kilowatt hours. Okay. Because you're going to see kilowatt hours divides out. This is dollars per day, dollar amount per 1 day. But what about for 365 days? So you got to do 365 by 1 year. We want to do this per year, by the way, so the days divide out. So now we got, I have to put this calculator above this, but here you're going to have 10. 10 times 10 times 0.11 times 365 divided by 1,000. So per year would be $4.015 per year. Now for the yearly savings. The yearly savings, I'm going to subtract that $4.015 from the $20.075. And you'll end up with $16.06. So how much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light using only 10 watts of power? It'll be $16.06. Okay. All right, the last thing I need to cover in this section, in this video, by the way, units of density and concentration. The terms density and concentration arise in a variety of different contexts. Like density describes compactness or crowding. Okay. Like material density is given in units of mass per unit volume. Population density is given by the number of people per unit area. Now back to material density, we use like grams per cubic centimeter. Population density, we use people per square mile. Now for information density, that's given in units of mass per unit volume, like gigabytes per square inch. Okay. Now for concentration, that describes the amount of one substance mixed with another. So the concentration of an air pollutant is often measured by the number of molecules in the pollutant per million molecules of air, like parts per million, ppm. Sometimes parts per billion, which is ppb. Blood alcohol content describes the concentration of alcohol in a person's body, like grams of alcohol per 100 milliliters of blood. And also medicine doses often require calculations based on a recommended concentration per kilogram of body weight or on the concentration of an active ingredient in a liquid suspension or IV drip, like milligrams per milliliter for a concentration of medicine in a liquid suspension, or milligrams per kilograms recommended doses per body weight. All right, then we're going to look at these last three examples in this video that deals with density and concentration. So like in this one right here, in 1940, a certain country's population was 77,971,935, and its area was 2,884,371 square miles. In 2000, the country's population was 281,991,219, and its area was 3,713,399 square miles. Compute the population densities of both years. Okay. So the fact is that the population density is equivalent to the population divided by area. Population divided by the area. All right, so now we're going to find the population density in 1940. So the population back in 1940 was 77,971,935. That's divided by The area back in 1940 was 2,884,371. So this is just a simple division problem here. 77971,935 divided by 2,884,371. We're going to round to the nearest whole number. And that would be approximately 27 people per square mile. Because the population represents the number of people, our area was in square miles. So 27 people per square mile. All right, now we'll compute the population density in 2000. That's going to be the population in 2000, which was 281,990. Well, I mean, 281,991,219 divided by the area in square miles, 3,713,399. So if I was to type this in the calculator, so the nearest whole number would be approximately 76 people per square mile. $76 people per square mile. Okay. All right, here's another example. This one deals with dosage. A certain antihistamine is often prescribed for allergies. A typical dose for a 100-pound person is 22 milligrams every 6 hours. Here we're going to complete parts A and B. In part A, following this dosage, how many 13.6 milligram chewable tablets would be taken in a week? All right. Now let's look at the fact that we have 6, but one dose is 6 hours. That will mean in a 24-hour day, (24 divided by 6) is going to be 4 doses per day. And in a week, there's 7 days in a week. So if we do 24 times 7, 7 times 4, that would be 28 doses per week. Now, of course, you can use unit analysis if you like, okay? But here we got a 22 milligram dose every 6 hours. So 22 milligrams per 1 dose. And this person is going to be taking 28 doses in a week. So the 28 doses goes in the numerator and 1 week goes in the denominator. You're going to see your doses divide out, you'll be given in milligrams per week. But we want to know how many tablets it's going to take. In this case here, each tablet is 13.6 milligrams. So one tablet is 13.6 milligrams. So I'm going to put the 13.6 milligrams in the denominator and one tablet on top, because we want to know how many chewable tablets it's going to take. The milligrams divides out. So if I do 22 times 28 divided by 13.6, we're going to round that off to 45. So it's going to be 45 tablets per week. So this person will have to take 45 13.6 milligram chewable tablets in 1 week, if that person wants to follow that particular dosage. Now, part B. This antihistamine also comes in a liquid form with a concentration of 13.6 milligrams per 8 milliliters. Following that prescribed dosage, how much liquid antihistamine should a 100-pound person take in a week? All right. So the typical 100-pound person takes 22 milligrams for one dose. And we established that the person is going to be taking 28 doses in a week. So the 28 doses goes in the numerator. 1 week goes in the denominator. Okay. All right, now, you're told in this problem here that the liquid form of the antihistamine has a concentration of 13.6 milligrams per 8 milliliters. Okay. And by the way, you'll see your doses divide out. You'll be left with milligrams per week. So let's find out what it's going to be in milliliters per week. So the 8 milliliters will have to go in the numerator, and that 13.6 milligrams goes in the denominator. So here your milligrams divides out. You'll be left with milliliters in a week. By the way, milliliters is the liquid amount of the antihistamine. So 22 times 28 times 8 divided by 13.6. To the nearest whole number, it'll be 362 milliliters in a week. That's the amount of liquid antihistamine a 100-pound person should take in a week. All right, and finally, number 23. A typical glass of wine contains about 20 grams of alcohol. Consider a 118-pound woman with approximately 6 liters or 6,000 milliliters of blood who drinks 2 glasses of wine. Complete parts A and B below. In part A says if all the alcohol were immediately absorbed into her bloodstream, what would her blood alcohol content be? All right, now it says here a glass of wine contains 20 grams of alcohol, but she drinks two glasses of wine. So we got to do 2 times 20 grams because she had 2 glasses of alcohol. Each glass contains 20 grams. And that's going to be divided by the number of milliliters of blood in her body. That's 6,000 milliliters. So in this case here, if I do 2 times 20 divided by 6,000, you're going to get 0.0, and I forgot to do something here, times 100. Because that's going to be a decimal, I need to convert this to a percent. Okay, because usually it's going to be usually your blood alcohol content would be in a percentage. So I'll multiply that by 100, it will be this point. Okay, 2 times 20 divided by 6,000 times 100. Okay, 0.67, rounded to 2 decimal places. So it'll be 0.67 grams per milliliter. That's her blood alcohol content. And usually the legal limit is 0.08 in most states. This would be a dangerously high blood alcohol content, okay? And this will probably, more than likely, will get arrested for driving under the influence with that high of a blood alcohol content. Part B, again, assume all the alcohol is absorbed immediately, but now assume her body eliminates the alcohol through metabolism at a rate of 9 grams per hour. What would be her blood alcohol content 3 hours after drinking the wine? All right. So that means here at a rate of 9 grams per hour, 3 hours after drinking the wine, we're going to multiply that by 3 hours. You'll see the hours divide out. That means she got rid of 27 grams of alcohol. So now the new amount of alcohol that was the 2 times 20 grams because she drank 2 glasses of wine, each 20 grams of alcohol in it. We're going to subtract off the 27 grams that she was able to get rid of, her body was able to metabolize. So 2 times 20 is 40. Subtract 27 from 40, you're going to get 13 grams. That's still in her system. Now we're going to take that 13 grams, divide that by the 6,000 liters that's in her blood, times 100. This time it's going to be 0.22, rounded to 2 decimal places. So in her body, there's 0.22 grams per milliliter of alcohol. Now, again, this is a little less than 3. Now, this time it's a little less than 3 times the legal limit of 0.08. So in reality, this would be dangerous for her as well. Okay, so that finally concludes this video on section 2B, dealing with unit analysis, extending unit analysis. I realize that this was a lengthy video, but try to get as much of this as you can and try to do the homework for this section, if at all possible. Feel free to reach out to me if you have any questions about anything presented in this video or any other homework problems that are in my math lab.